Now, frequently used QPX functions, I listed them here. They are very similar to the MSUM functions. This is pre-open. Let's read the name. So QPX, which is the extending, is an event of the network when network is pre-opened, which means before the network is opened. So when NSUM load when Paramex loads the network, before it loads the network, it will execute this pre-open function. And after the network is loaded, it will execute the post-open function. Then for each time step, there is a time step function. And there is a time step post-link function, which are corresponding to the manage and post-manage functions in NSUM. Now here is a close function which will be loaded after the simulation is closed. Here are two functions that MSUM doesn't have. This is QPX vehicle release. In this function, whenever a vehicle is released, which means that when they are loaded onto the network, this function will be executed, and the released vehicle will be given to you as a pointer, as a vehicle type pointer. Vehicle is a predefined structure or class in a structure in Paramex. So they will call your function and they will give you the vehicle that has just been released. And when a vehicle has arrived at its destination, this function arrive will be called. So Paramex will give you the current vehicle ID or vehicle pointer and the current link pointer and current zone pointer. All right? No question? Let me give you the first example. So this is a framework that I typically use when I develop my Paramex plugin. So this is the whole source code. In the beginning, we have to include a header file called programmer.h. Then we have other includes we need. Then we use namespace Paramex plugin, but this is not something important. This is for myself. So in this namespace, I defined a class. I created a class called vehicle manager. So I have a vehicle manager that can process all the vehicles. This is created by myself. Now the first function is called is implemented here. Is the post open. So very simply, I want to show this string in the output area after the network is loaded. So this is QPS, graphic user interface, printf, and this function is going to show you a string. So after I just want to confirm that my network has been loaded, by using this code, this sentence, I can ensure that the plugin is working. Because sometimes the plugin is not loaded, so I want to make sure the plugin is loaded by adding this printf function to this post-open function. The second function to write is called vehicle release. So when the vehicle is released, simply I declared another pointer. But the type of this pointer is called Paramex vehicle, and this is defined by myself. I generate my vehicle class, my vehicle instance, using the existing vehicle pointer. So I created a new object called Paramex vehicle, which is defined by myself. Then I add this newly generated vehicle into the vehicle manager. I add this to vehicle manager. So whenever a vehicle is released, I will add this vehicle to my vehicle manager. The third function is time step post link. And this function, I will call my vehicle manager. I will call a method called manage vehicles, which is defined by myself, to process all the vehicles that are handled by the vehicle manager. So this is another function that I implement. So for each time step, I will call this function to manage vehicles. After the vehicles arrive at their destination, I am going to remove this vehicle from my vehicle manager. And this is function to get the vehicle ID by this pointer. One thing I want to add is, although they give you this vehicle, the pointer to the vehicle, they don't give you the structure of this pointer. So they won't tell you how this vehicle is implemented. They only give you this pointer. In order to get all the information stored with this pointer, you have to use their provided QPS or QPG functions. So it's unlike our daily use of pointer. So when we use pointer, typically we get a pointer and we execute some methods that are related to it that can be found within the pointer. But in their case, you have to use their function to get their attributes. For example, we have a pointer to this vehicle. Then we use this function to get the ID of this vehicle. Right? Now, when the network is closing, I call my vehicle manager to clear all the vehicles that are stored in it, to release the memory, right? So this is my framework of using a vehicle manager. So here I'm not showing you the implementation of the vehicle manager, but it's a framework that you can use. Any question about this?
In your parameter list, did you define all the types?
The types?
Yeah.
All these types are stored in this programmer.h, which parametrics defined.
Oh.
So that's why we can use these vehicle things. They are defined in this header file. You can check this file. Right?
So what's the advantage behind using the vehicle manager? What's the advantage behind doing it this way? It seems it's a clean way,
yes.
But I won't want to...
The first advantage, there are several advantages. The first advantage is my vehicle manager is not written in C++. It's written in my C# code. Oh, no, it's not C# code. It's still C++, but it's managed C++, which means you can use the latest techniques in .NET framework, such as garbage collection. So there will be less memory leak.
Okay.
So it's safer. Another good thing is this framework, this main program becomes clean, very clean. And the third thing is, in premise, when they call your functions, for example, when they call this function, times that post link, you will have to make a query to get all the vehicle IDs, which is a waste of time. If we have already stored it somewhere, then we can directly access it. We don't need to make the query, right? So in this function, they call this function. You want to process all the vehicles. Then how do you know where the vehicles are, or what their IDs are? You have to query.
So what does the vehicle manager do exactly, like the function that you provide? It keeps track of all the vehicles. What else does it do?
It can perform everything we want. So this is a part of my intelligent intersection project. So basically, vehicle manager is doing everything. I'm going to show you a bit more detail in the next example. Okay, so here is an example. I simplified everything. So this function is going to avoid collision. We want to implement this avoid collision thing. By default, the collisions are already avoided because Parametrics has a car fouling model. But because my program modified their behavior, I have to implement this collision avoidance by myself. So this is a function. This function has no return value, but it has an input, which is the vehicle pointer. Now we first define another pointer called the vehicle ahead. Then we use this function, QPGV vehicle ahead, to get the vehicle that is ahead of this vehicle. So this is a function provided by Parametrics. I can get a vehicle ahead. Then if this vehicle ahead is not now, So I want to tell you this, this format, this style is not very professional because in language C, they typically won't add this part. It's not equal to null. Because when a pointer is not equal to null, this Boolean statement is already true. So only this will they will implement it, write it as if vehicle ahead. But I want to make you all understand this. So I say if the vehicle ahead is not null, null means a null pointer, a pointer pointing to 0. Then this will indicate there is a vehicle ahead of this vehicle within the same link. Then we can use this function to get the distance between a vehicle and the center of intersection. So in parametrics, they don't provide a function to get the distance between this vehicle and the vehicle ahead. However, they provide a function to get the distance between a certain vehicle and the center of intersection. So we can use that indirectly to calculate the distance between the two vehicles. So we get a float variable indicating the distance of this vehicle to the center of intersection using their function. Then we use another function to get the distance between the ahead vehicle and the center of intersection. So their difference will be equal to our relative distance. And here is a function that is implemented in .NET framework to calculate the absolute value. So we get absolute value, absolute difference between them. Ideally, we don't need this absolute because this distance will always be larger than distance ahead. But I just want to make sure it's safe, make it safer. So it's a bit redundant. Now the speed of this vehicle can be get by this function. Get vehicle speed of this current pointer. Then we can get the speed of the vehicle ahead. So we can get our speed difference. So let's say currently we have a gap. And if the speed difference within a second is larger than the gap, that would mean my vehicle will hit that vehicle. Alright? For example, distance is 5 meters, and our speed difference is 6 meters. And my vehicle is driving faster. That would mean in the next time step we are going to have a collision. So if this distance is less than the speed difference, we can use this QPS function to set the current speed of this vehicle to be the maximum of speed vehicle ahead in 0.0f, which means 0. So I want to make sure it's above 0. Because sometimes parametrics, the vehicle speed may be negative. I don't know why they did that. Maybe it's a bug. But I just want to make sure it's above 0. So it's maximum of the speed vehicle ahead. So if I set the speed according to the speed vehicle ahead, that would mean our speed difference is 0. Then we